Good evening. Thank you for watching. So before I even get into my next video, I just thought I'd include this at the beginning just to outline an important point related to PIC18F chips. And this is the PIC18C or 18F MCU family reference manual. I'll try and remember to leave a link for this below if you're looking for it, and I will just read. So this is on page 659 of the PDF, section 31, instruction set, data memory map. The data memory map has 16 banks of 256 bytes. The instruction set and architecture allows operations across all banks, such as MOVEFF. A segment of bank 0 and a segment of bank 15 comprise the access bank. See section 31.2.1 for description of the access bank. And here's figure 31.1, the data memory map and the access bank. And this is unique to the 18F family. So if you're using older families of PIC chips, like the 10F, the 12, the 16F, those family of chips put the special function registers at the top of the memory map, and in 18F they put the special function registers, and they're showing that here. The special function register is in bank 15, so they're putting the special function registers at the bottom of the data memory map. So that's different in the 18F family, and I just wanted to point that out. I had to look it up myself, and that's because, I'm getting off topic now, but I want to include a counter, and I'm using an equate to do that, and it requires me to select a data memory location. So in fact I'm going to use 0x00 because I can use the very first data memory location for the 18F chips. I hope that's clear. I'm covering this because I needed a reminder of it myself, and for reference here at home, P23 of my own reference manual I'm using. You listening aren't going to know what that means. Okay, thanks, and now I'll get into my video.
Alright, so this isn't working correctly. What I was hoping to do is increment a byte in a GPR file register location, and then you would see the different LEDs counting in binary. Well, that's not happening. So what's going on here? Should I add a capacitor in here to smooth out the supply? I really don't know what's happening, but I know that this pin RC0 is the input. So there's probably something incorrect. Well, I don't know what the problem is, so something's not right here.
Good evening. Thank you for watching. I do appreciate it. So this is something I worked on yesterday. Since then I almost forgot what I did. Almost. This code will take a file in a general purpose register, and I've already given the very first GPR a name. I've called it R1. That's the equate I've given it. And then I initialize my chip. I put the org directive in. I set up my internal oscillator. Just to be sure, I clear R1, which is the counter. GPR I created. Then I clear trice D, which makes port D an output. And I set F trice C, which makes port C as an input. Then I created a label for my main loop, and I'm using the move FF instruction. And I'm taking the contents of R1 and I'm sending it to port D. Now intuitively, maybe that's not the beginning line of code to understand what I'm even doing in my program here. The thing I'm doing is I'm incrementing this file I defined, and I'm basically creating a counter where I'm going to count from 0 to 255. And I'm outputting that on port D. So it will blink the binary numbers contained in R1, and it will blink them as it increments from 0 up to the count of 255. So I'll begin explaining here again. So there's a label again, move FF R1, so whatever's contained in that first file, the GPR, move it to port D. Port D is set up as an output port, all 8 pins. The next instruction, bit test F, skip if clear. And I'm going to take a single GPIO pin on port C, specifically RC0, and it will test the input. And I have a 555 timer doing its duty cycle of pulsing on and off. And I have that sending its signal in to RC0. So depending on the blinking of a 555 timer, every time it blinks, it should increment this R1 GPR RAM file. And this next line of code does that. If RC0 is receiving a high signal, it will increment R1. Now that created a bit of a challenge in my coding, and I'll try and explain why. I want this R1 file to increment every time the signal goes from low to high. But this code, and the microcontroller in particular, iterates so quickly at 400 megahertz that it will constantly run through this code, checking the 555 timer signal on RC0, and by operating at the speed it does, it'll constantly check and check and check and check, and the signal will very often be high, many hundreds or even thousands of times per second. So I needed to come up with some way, using assembly language, to only increment R1 when the signal goes from a low to a high. And that's what this separate loop is going to remedy. I'll get to that. So I'll start back here with explaining. I know we've already covered this twice already now. But anyway, there's this again label. Moves the contents of R1 into port D. Why do we want to do that? Well, we're incrementing R1 every time there's a high on RC0. And then we're going to bit test the file and skip if clear. So RC0 is going to check, are we receiving a high? If we are, then don't skip the next line, it'll increment. If it's clear, meaning it's getting a low, it'll skip this line and go here. This line is bit test F, skip if clear. So once again, it's checking if RC0 is getting a high or a low signal. If it's clear, it'll skip this next go to line, and it'll go to again, and it'll just go back up to the loop again. But after it increments once, it'll bit test if this RC0 signal is still a high, and if it is, and it's not clear, it won't skip this next line. It'll go to this no-op subroutine, perhaps call that, and here's the no-op label, because I pretty much want this subroutine to do nothing as it iterates through. So once it breaks out of this loop, because RC0 is high and it doesn't skip this next line, and break goes in here, it won't let the microcontroller get out of this loop until RC0 goes back to a low signal. Bit test F, skip if clear. Once it's clear, it won't read this line, it'll go to this, and it'll make it jump back to the loop, and it'll iterate back into this loop again. So basically this subroutine won't let the microcontroller go back and iterate through this main loop until we are sure that the 555 timer is sending its low signal and port C RC0 is clear. Otherwise, once again, the 555 timer is too slow that it would constantly check multiple times during the same high signal of the 555 timer, and so it would count up from 0 to 255 way too fast. So I had to make sure that I was only incrementing this R1 GPR from a low to a high signal, and not again while the 555 timer signal is high. I know if you're tuning in and you're listening to this, it's very hard to understand somebody else's idea, and it's a very technical thing to explain, and words are almost are insufficient to really explain things. So I'll try and explain this differently. So here is the 555 timer, sending out its high and low signals, equal time low, equal time high. And then the microcontroller, and in my case in particular on pin RC0 as an input, is going to check whether the signal incoming is high or low. Unfortunately, the microcontroller iterates many thousands of times per second so quickly that when it checks again and again and again, even on the same pulse, from the same pulse strain, but even on the same pulse high, it'll check it many times, and it will basically increment that R1 many times within a second. So I really needed to create code that only incremented this R1 GPR file that I designated on the trigger edge from a low to a high. So when I originally wrote my code, I didn't do this satisfactorily, and what's visible on my breadboard setup wasn't working. So I basically had to create a situation where I create this second loop, and it won't let the microcontroller go back into the main loop until we know that the incoming signal has gone from high to low again. Unfortunately, I didn't document my original erroneous code that I wrote that was not working properly, so I haven't documented that in this video. But this is the real trick here, was not allowing the microcontroller to go back to the main loop until port C received an input and port C was back to a low signal again. Then it would release the microcontroller to go back into the main loop. Another minor problem I had in my coding, and I'm still learning, is that I was using return statements, which really aren't opcodes, and I was using return statements to get it to go back into the main loop. I even wrote myself a comment, a note to self explaining that. My original program did not like my return statements, so I just substituted those with goTo statements. And I added a label here called this. Maybe that's not the best way to do things, but my use of the return statements was not accepted by MPLAB. It didn't like it, so I couldn't use that anymore. So I just put in goTo to bring it back here to iterate through the main loop again. Well, thank you very much for watching.
Okay, so here is my breadboard setup. So I'll just explain a little bit about my setup first. So this is a 555 timer, and you can see it blinking here. I can slow it down really slow. And the 555 timer, in a roundabout way, into the breadboard here, and I've got it grounded with a pull-down resistor, just so hopefully the circuit operates better when I do that. And then I've got it coming out this end with this green line into pin RC0 of the microcontroller chip. And I just grounded RC0 pins just to make sure there was no stray capacitance or something on the other port C pins. Port D is hooked up to all these blue jumper wires into port D, so there's 8 of them. A few of them go over this way. So RC0, which is this line here, is going to take the input from the 555 timer. When it receives a high signal, it'll increment that R1 GPR, and then that main loop takes the R1 file and it move FFs them, that file, out to port D. This circuit might work a little bit better if there was a shorter on time of the 555 timer signal, but it's okay, it still works. The M-Clear button works. I left that on. Just clears it, brings it back to the beginning.